Hi everyone. For this video, we will continue with step number 6 for uh, finding a selections set for LL1 grammar. So for the steps number 6 is to compute the relation is followed directly. So it's followed directly by the short form would be FDB. Okay, so BFDBX, if there is a rules of the form A goes to alpha, B, beta, X, and sigma. So where beta is a string of nullable non-terminal, alpha and sigma are string of symbols, X is any symbols, and AB are non-terminal. So we need to find the followed directly by. So in this case, if you look into the grammar G5, the rules that have this format, this form, A goes to alpha, beta, alpha, B, beta, X, sigma is rules number 1. Okay, rules number 1 where it contain nullable as well as some strings of terminal and non-terminal. Okay, so we are interested on the right hand side of the rules, which is A, B, C. So followed directly by means that what will follow directly after each of the string. So we start with A. Okay, we start with A. What followed directly after A is B. So we write down A followed directly by B. Then move to the next one is B. What followed directly after B is C. So we write down B followed directly by C. Okay. Uh, Note that if B were a nullable non-terminal, we would also have A followed by C. This is only happen if B is also a nullable non-terminal. But in this case, in G15, B is not a nullable. Okay, it's just a normal non-terminal. It's not a nullable. So we only have to followed directly by pair in these steps number 6. For step 7, now we want to compute the relation is direct and off. So DEO, X is DEO A if there is a rules of this form. Okay, A goes to alpha, X beta. So where B is a string of nullable non-terminal, alpha is a string of symbols, and X is a single grammar symbol. X is a single grammar symbols. Okay. So what does steps number 7 want is they want the direct and off. They want to determine what is the direct and of each of the rules that we have. Okay, except for the nullable non-terminal. Okay, so for rules number 1, okay, the end of the rules would be C. Okay, this is the end of it. Okay, so for rules number 1, C is the direct end of S. So we write C is the direct end of S. Now we move to rules number 2. The end of the rules is A. So we write A is the end of A. Okay, C is the end of S. A is the end of A. Okay, but for second rules, if A, because A is a nullable, so it means that A can be instantiated into epsilon. It means that the rules number 2 also can end with B, means that it stops here. Okay, because A is nullable, rules number 2 also can stop at B. So we say that B is the direct end of A as well. Next one is the nullables, non-terminals, so we skip. So next one is rules number 4 is C is the direct end of B. Okay, so C is the direct end of B. So this is steps number 7 to find direct end of. Next, we move to steps number 8 is to compute the relation is and of. So is and of, we want to find the relations reflexive, transitive, closure from DEO. DEO is from steps 7. So now we want to find reflexive transitive closure from steps number 7. So to find reflexive transitive closure, there are 3 steps. First is to write down the DEO itself, the rules, the pair from DEO. Next is to find the transitive. Third one is to find the reflexive. So the first one is to copy from the DEO. You have 4 pairs here. Okay, so in this case, there is no transitive. If you look carefully into the DEO pairs, there is no transitive in this pair. Okay, so for the reflexive, we have 4 reflexive here: C, C, S, S, B, B, and capital B. Okay, capital letter B. So this is for steps number 8, is to compute the relations is and of. Okay. Next, we move to steps number 9. Steps number 9 is to compute the relation is followed by. So for steps number 9, it needs input from steps number 8, steps number 6, as well as steps number 3. If you refer to the dependency graph, you will see that steps number 9 need to have an output from the steps 8, 6, and 3. Okay, so if you look into the definitions, WFB is followed by Z if there is a string derived from as and marker. So in which W is immediately followed by Z. So we want to know W is followed by Z. So how? Then we need an output from EO, which is from step 3. We need an output from FDB followed directly by with step 6, and also BW, okay, from steps number 3. So it starts with steps number 8, so WEOX. So it must be when it ends with X, so the next step X must be the same with the one that start in FTB from the steps number 6. Okay, and the same thing here. The output from the second pair of the FTB must be the same with the first one of the third steps. Okay, so how to do that? So we need an information from step 8, 6, and 3. If you look it down here, we only took 4 from the EO, the end of while in the step 8, as they have add all together. Okay, add all together, but we only take 4. So how? If you look closely into step number 6, okay, step number 6 only contain 2 pair. So the first pair is start from A, and the second pair is B. So what you need to do actually, you need to find the second pair, the second string from the step 8, which actually is A and B. So in this case, on the step 8, the second string actually will be on the second pair that have A. The third pair also the second string is A. Okay, no more. And then the one that have a second string B on step 8 is the fourth one and also the last one. So that's why you only have 4 in your steps 9 for EO. Okay, you only choose 4. And then you copy the 2 pair from FTP. Okay, next one is to find element, the pair for step 3. So how? So you look into the step 6, the second string is B and C. So the one that start the first string in steps 3, that is B and C, is the fourth one, the third last, second last, not the second last, the last one. Okay, that is the one. Okay, so how to find it? So you start with AEOA with the AFDB B. So it ends with B. So you need to start with the one with B. Here is B goes to B and B goes to C. Okay, that's 2. And B for the second one here, for the second EO, BEOA. Okay, then go to A, FDB, B. So it also have B, BWB, and B, BWC. Okay. The third EO, BEOB, okay, that goes to B here. So BFDBC will go to C, BWC. Okay. Next is the last EO, CEOB. They go to B, FDBC, and they go to C. So for C, they only have one that starts with C. Okay. So now this is the list of BW from step 3 that you choose. Okay. So there are 6 altogether. So what will be the FB followed by? So the followed by would take the first string from the EO and the last string from BW. Okay, the second string from BW. So the first for the A followed by B. So you took here from A and B. Okay, so this is for the first one. For the second one, A followed by C is A followed by C. Okay, so this is for second one. And for the third one, it is from B and B here. The fourth one is again B and C. Next one is B with C. And last one C with C. So this is the output for step number 9 followed by. So step number 9, they need output from step add 6 and 3 in order to get that followed by result. Move to steps number 10 is to extend the followed by relations and to include the end marker. Okay, to include the end marker. So followed by end marker, if A is end of S, where A represent any non-terminal and S represent the starting non-terminal. So here for step number 10, we need to look a pair inside EO. So EO from the step number 8. Okay, so I copy it here. This is the EO that we get before this. So we look into A, E, O, S. So A can be any non-terminal. So look at these kinds of pair. Okay, any non-terminal, E, O, and S. So if you look here, the one that have a second string of S is the first one and the third last. Okay, so but the one that we have a non-terminal as the first string of the pair would be the third last here. Okay, the one that third last here. So on the step 10 here, it said to extend. Extend means to add another one of followed by. So the one that we get followed by that we get from step 9 is only 6. Now we add another one, which is S FB S. So now we have 7 followed by all together from the step number 10. Now step 11 is to compute the follow set for each nullable non-terminal. So how many nullable non-terminal we have in this example G15? 1, which is A. Now we want to find the follow set for A. Okay, step 11 is just to find the follow set for each of the nullable non-terminal. So in this case, we only have one nullable non-terminal, which is A. So we want to write down follow A. In this case is C, since A is the only nullable non-terminal in this G15. So we say that A from the followed by, we see the result A followed by C. So we say that follow A is C. So how do you get C? Is from A followed by C. Okay, so that is where we can get follow A. Follow A is equals to C. Finally, we come to the end of the step, which is step 12, is to compute the selection set for each rules. Okay, so in this LL1, we have a grammar in this form. A goes to alpha, where alpha can be terminal or non-terminal. So if rules I is not a nullable rules, then the selection set I, we took it from the first alpha. If rule I is a nullable rules, then the selection set must be first alpha union with follow A. Okay, so that is the how we find the compute the selection uh, set for LL1. Okay, for G15, for rules number 1, select selection set for rules number 1. So it is a first alpha. So first A, B, C, we have computed before we get B, C. Okay, on the selection set for rules number 2, we have the selection set is B. And for rules number 3, it is before this is empty, is epsilon. So first epsilon union with follow A. So empty union with follow A is C. So you get selection set is C for rules number 3. For rules number 4, the selection set is you take the first C. Okay, first C is equals to C. Selection set C. Set C. So this is the result, the output of a selection set for grammar G15 LL1. So this is for all of the rules, you already determine, identify what would be the selection set, what will be the string that will indicate which rule to derive first. Okay, which rule to derive first in the derivation tree. If the rules number 1, it can be B, C, rules number 2 is B, rule number C is C, the third rule is C, and the fourth rule is C as well. Now we look into the pushdown machine for LL1 grammar. We have found the selections set for each of the rule inside the G15. Now we can construct a one-step pushdown machine for a G15. Okay, why selection set is important here? Because you want to be able to construct a one-step pushdown machine. Okay, so from the result that we get from the 12 steps that we have followed, we have rule number 1 is PC, rule number 2 is P, rule number 3 is C, and rule number 4 is C. So this information is important for you to construct the pushdown machine. Okay, so to construct the pushdown machine is the same as the previous video on the pushdown machine for the quasi-simple grammar. Okay, we follow the same steps as well. Okay, so for the initial stack marker and the end marker, we put accept. Okay, this is the first step, and the first rules here. Okay, for the S, A, B, C. So every time we see a letter B and also input string B and C, so we just replace with CBA. Okay, replace with CBA and return. Okay, and what about rules number 2? Rules number 2, when we see B, okay, B, we want to see B, then we put that pop, we replace it. When we see B, we put it replace AB and return. Okay, and then for rules number 3 is on C. Okay, C. So we replace when we see C, so replace C and return. Okay, and then rules. Okay, for rules number 3 actually is here epsilon. Okay, when it is epsilon, when it reach C, okay, for selection C, it sees C, then you have to pop and return. Okay, this is for rules number 2. Okay, here 1 and 1. Okay, so the next one is you pop and advance when it is the same input symbol. Okay, the same input symbol is pop and retain, pop and advance. The rest is reject. Okay, that is how you do it. Okay, the last part of the LL1 grammar is to construct recursive descent. It's also similar to the one in the quasi-simple grammar. Is how you construct or develop your code, a Java code, a method for each of the non-terminal that you have in your grammar. So here we have a void S, void A and B. So because this is the non-terminal that we have, so for void S, we have an input. Remember, we find the selection set. We have B and C. Okay, to determine when it is A, then you choose B. When the non-terminal is B, then it's C. And for void A, there are two as well. One of the rules number 2 that start with B, but rules number 3 we have find the follow A, which is C. Okay, then B is quite straightforward from rules number 4. Okay, so that is the end of our lesson for LL1 grammar. Normally, the most important is to find the selection set for the epsilon for the nullable, actually for the nullable non-terminal. So the step is quite a lot. There are 12 steps altogether to find the follow set and the first X whatsoever in the algorithm, so that you can use it in your pushdown machine as well as the recursive descent for LL1 grammar. Okay, this is all for this chapter. Uh, Thank you very much.